Now, as we go ahead and take a look at question number 2, rather, question number 2 now switches the shape up and we head towards quadrilateral. Any quadrilateral has to have the sum of its interior angles equal to 360 degrees. You know this from square and rectangle, because when you have 4 right angles or 4 90-degree angles, they have to add up to then make 360. That's true for any quadrilateral. Doesn't matter if it's a trapezoid or a parallelogram or a rhombus. They all have interior angles that add up to make 360 degrees. So we're going to do the same thing here that we did in question number 1. The only difference is obviously we've got 4 components to put together, and our sum total needs to be 360 as opposed to 180. So we're trying to find the unknown measure, which is the bottom right angle here marked X. So what we're going to do is say that this angle here, which says 89, plus this one here, which says 65, plus this one here, which says 82, plus this one here, which says X, has to add up to make 360 degrees. Well, as you can see, once again, they're doing that in solving equation form. So what they're doing here is they're going to add together the 3 numbers that we have there on the left side. We've got the 65, the 89, and the 82, which they're putting together here to make 236. You still got our X, because I can't do anything with that. He doesn't combine with anything. And I still got our 360 here. And now I'm going to again solve this like I would solve an equation. Again, when I do this here, I want to keep the variables on the left and move the numbers off towards the right. So in this particular case here, X, the variable, is going to stay here on the left, and 360, the number here, is going to stay on the right. So that means 236, the other number, needs to get kicked over to this right side. How do I do that? Well, I do the opposite. Opposite side, do the opposite is the rule for solving equations we've always used. So I'm knocking 236 off both sides here, and I've got 360 minus 236. 360 minus 236 changes into 124. When I do that, that's going to be the measure of my fourth and final angle. So we scroll down here and take a look at number 3. In question number 3, we're asked to divide the polygon into triangles and to find the sum of its angle measures. Now, this is a good question because it gives us a chance to talk about how we can find the sum of the interior angles for all the other shapes that aren't 3 and 4 sided, which tends to be a little bit more work. As you can see here, we've got 1, 2, 3, 4, 5, 6, 7, 8 sides going around here, so obviously this is an octagon. Octagon, of course, as you know, is because we just counted it out, has 8 sides. What they did here is the process known as triangulation. What you do in triangulation is you pick a corner of the shape and you draw a line to every other corner of the shape. Now, as you can see, a couple of them were already done. For instance, if I go to this corner, which happens to be adjacent to that corner, connected to it directly, it's already in line there. Same thing for this corner over here. But the rest of them all had to be drawn. That's the triangulation process because obviously we've created a bunch of triangles. Well, what's true here is, well, we've created 6 different triangles. 1, 2, 3, 4, 5, 6. Well, how does that help us? Well, it helps us because we know that one triangle has angles that add up to make 180 degrees. So if we've got 6 triangles, we've got 6 sets of 180 degrees, which is why they're doing 6 times 180, which generates here 6 triangles at 1,080 degrees total, which means, simply, that an octagon has angles that add up to 1,080 degrees. Now, how do they come up with that? Well, let's back up here. Let's go back up and look at number 2 for just a second. We already know what the sum of the interior angles of the quadrilateral number 2 was. But let's try the same thing here. Let's pick a corner and draw a line to every other corner. Well, that's pretty easy because I only have to draw a line to that corner. So we had 4 sides, and we ended up with 2 triangles. Interesting. Let's take a pentagon. Let's pick a corner. Draw a line to every other corner. 5 sides. 3 triangles. Interesting. Notice that the number of triangles we're generating here, 4 and 2, 5 and 3, 8 and 6, is always 2 less than the number of sides. Don't believe it? Well, let's try it again then. Let's go for 6 sides here. There's my hexagon. Pick a corner. Draw a line to every other corner. 6 sides, and 1, 2, 3, 4 triangles. There must be some type of relationship there. Indeed, that is the relationship. If you take the number of sides and subtract 2, that's always going to be how many triangles that generates. Well, that's really handy and convenient for us, because if I know how many triangles are generated, I don't have to draw them every time, which saves me a bunch of time here. And that's a good thing, because that's going to help us write down a formula. Formula you want to learn here is n minus 2 times 180, where n is the number of sides. What does this formula give you? Well, this formula gives you the sum of the interior angles. Anytime I change n into how many sides a shape has, and then subtract 2, and then multiply by 180, I'll always get the sum of the interior angles. That's great, because let's say I give you a 102-sided shape. Do you want to take a 102-sided shape and then draw all the triangles and then count how many triangles there are and then multiply by 180? No, of course you don't. It's much easier to take a formula. 102 minus 2 is 100. 100 times 180 here, it generates 18,000. Done. Figured it out for me. The formula did it much quicker than I can draw the triangles and then count them up and then multiply by 180. You can use this formula in your homework tonight. Just take the number of sides, subtract 2, and then multiply by 180, and that'll give you the sum of the interior angles of a shape. Alright, so let's look at the concluding question here. To check it out, example number 1, they're asking me to find the unknown measure in the triangle. Well, obviously it's a triangle, so it's got to add up to make 180 degrees. Now you might be looking at this and saying, well, wait a minute, they only gave us one angle. Not really so. This bottom left corner here has a right angle mark on it. So that angle we know has to measure 90 degrees, even though it doesn't say 90 degrees. So what I have here are 90 and 30, or 120, plus the angle that they're asking me to find, x, has to equal 180. Well, written in solving equation form, we knock 120 off both sides, and we find that my missing angle must measure 60 degrees. So this angle right here has to measure 60 degrees.